Back. So in this tutorial, we're going to have a look at the differentiation of an expression or expressions involving log base e to the x, otherwise known as the differentiation of the natural logarithm. Now, when we consider our natural logarithm, we can write an expression just written as y log e to the x, and then by the rule dy dx is given as something, or given as 1 on x. So this is quite a unique derivative for the natural logarithm, and part of the explanation of why the natural logarithm actually exists. We won't get stuck into that, but what I want to explore here is what happens when we have a composite function with a natural logarithm. So let's explore a composite function writing the natural logarithm with another function embedded in it. So hx equal log e to the function of fx. So what we're going to do here is we're going to say let u equal fx, and we would explore du dx. That obviously gives us f dash x. And then we would say therefore y equals log e to the u, and dy du equals 1 on u, or we could say 1 on fx if we substitute fx for u. And therefore we get dy dx equaling f dash x times 1 on fx. And we can express this in terms of h dash x, the derivative of hx, and that would just be expressed as f dash x on fx. So when you're dealing with expressions involving natural logarithms, you must remember this basic principle of dy dx of the natural logarithm is 1 on x. And also this rule here of when you're going to deal with composite functions. So we're going to move forward and we're going to look at 3 examples taken from the textbook. And each of them is asking how to differentiate some expression involving a natural logarithm and to find different components of it. So let's start with question 5. And what we have here is fx equals log e square root x squared plus 1. Now there's different approaches we could take. We could treat this whole expression, or this part of the expression, as a function in itself and then use the composite function rule. But I'm going to actually bypass all of that and apply my logarithmic laws. So I'm going to rewrite fx as log e x squared plus 1. And I'm just trying to do this to make it a little bit easier, a little bit more efficient when we come to exploring the derivative. So I have here a half times this expression. Now when I come to deal with my derivative function, f dash x, that half is just going to drop down. And then I'm going to explore what is this derivative of this second part of the expression. So if I look at look at this part, I'm going to take the derivative of the bracket. So that's just going to be 2x, and then the original function, x plus 1. Now there is a nice cancellation, and all of you will know that I enjoy cancellations. Sort of just neatens things up, and I get f dash x equals 1 on x squared plus 1. Now this question is asking us to find f dash 1, so we're going to say 1 squared plus 1, and that's just going to give us a half, which is the correct answer. So if we look at question 6 now, and this just says to differentiate log e 1 plus x squared. I'm just going to write it as y. So write the expression as y equals log e 1 plus x squared. And then we're going to try to find the derivative of y, okay, in terms of x. And I'm going to derive the bracket first up. So that's going to be 2x plus 1, okay. I'm just going to make sure that when I derive it, I'm going to try to put them in order. I think it's just neater. And then I just put the bracket down as my denominator. And there we have the derivative. Quite easy. And then we come to question 7. And we have here fx equals log e x squared plus 1. Well, f dash x, we know what we're going to do here. We're going to derive the bracket, so 2x, all on x squared plus 1. And we're being asked to find what f dash x is when x equals 3, f dash 3. So I've got 2, 3 squared plus 1. This is 6 on 10. And f dash 3 equals 3 on 5. So as you can see, knowing the rules is really essential to dealing with natural logarithms, especially when you're deriving them. But if you can apply them and couple them with your logarithmic laws, there should be no issue. Okay, enjoy your day.